Hi and welcome to Geeks for Geeks. Today we would be discussing yesterday's problem of the day, that is find anagrams in linked list. So before that, belated happy Holi. Okay, fair enough. I think we can move forward itself. Okay, so let's talk about the feedback of this problem. The feedback of this problem would be that this problem seemed to be a medium hard level problem, but after analyzing it a bit and after analyzing the properties of anagram, we find that yes, it is easy enough to solve. And after analyzing or writing down in a pen and paper, we can say that yes, this problem falls under the category of easy medium. Now, without any further ado, let's get started. Okay, so I think we are good to move forward, and yep, this is. Sorry. So here we are given a linked list. So what is linked list? A linked list is a set of nodes which have a pointer to the next node. It has a pointer to the previous node also, and it is known as doubly linked list. So it has a pointer to the next node, it has a pointer to the next node itself, and this is how it works. And then you are told what is an anagram. So now let us understand what is basically an anagram. So anagram is a string. So suppose we are given A, B, C. So we can say CBA is an anagram. Okay. BAC is an anagram. But CCA is not an anagram. Why do we say this? This is because all the character should have the same frequency. Like here we can see that A has a frequency of 1, A has also a frequency of 1, B has a frequency of 1, B also here has a frequency of 1, C has a frequency of 1, and C also has a frequency of 1, and other characters have a frequency of 0, and yes, we can say that other characters have a frequency of 0 itself. Here also does the same, but here we can see the frequency of the character C is 1 in the original string, but the sequence in this one, the red one, has a frequency of 2 itself. So this is what is anagram. Now let's go back to the problem statement just a bit. Okay, so I think we can move forward. So here we are given a linked list. Okay, a singly linked list. And you are told to find all anagrams. Find all anagrams of given string. So what can be the problems? What can be the sample test case? Let's take up this sample test case and see. So here you can see that this one BAC. So I can say CBA is an anagram. Okay, or I can say ABC is an anagram, as well as BCA is also an anagram. Okay, and then we are again having BCA as an anagram. So here we are told that yes, these are the two anagrams that we have. But we are told that if we have overlapping anagrams, then the first anagram needs to be reported. So if we have ABC and BCA, then ABC would be reported. That is why the answer to this is ABC and BCA itself. Let us move to the second sample test case. If we have, yes, we have a second sample test case too. So here in this problem, we are told that we need to find an anagram of BAC, but we don't have anything as BAC. We don't have it. That is why the output to this is -1 itself. Okay, so we need to find all the anagrams. Okay, so how do we do that? So a string. So basically, what is basically an anagram? So I can say an anagram is nothing but a shuffle of the original string. Shuffle of the original string. So if an anagram, like suppose if we have ABC, then if we just shuffle it CAB, then this becomes an anagram. If we add more new characters, this does not become an anagram. If we remove some characters, it does not become an anagram. So a rearrangement of an original string, the rearrangement part is an anagram itself. Okay. So if the new anagram is a shuffle of the original string, then these both have the same length. Like suppose if we have a string and this is an anagram of S. Example, suppose we have here as CBA, an anagram would be an ABC. So they both would have the same length. Same length would be there. Of course, there would be same length. So if we have the same length, then we would use this thing. How we would use this thing? See, what we can do is, as the length is fixed. Okay, first we think of two pointers, like yes, ABC would be moving here, ABC would be moving there. So what are the ideas around two pointers? Two pointers are the ideas around two pointers, a sliding window. A sliding window is used when we have a fixed size. So when size is fixed, we can use a sliding window approach. How we can do that? Let me tell you that. Let's go back to this. Okay. Let's say that first we have a length of 3. So we know that the new anagram would be of length 3. So first we have ABC. We found out, yes, this is an anagram. Okay. Then we have BCA. Yes, this is an anagram. Then we have CAD. Yes, this is an anagram. Then we have ADB. No, this is not an anagram. And then we have DBC. This is not an anagram. Then we have BCA. This is not an anagram. So what we can do is, see, here also we found an anagram, and here also we found an anagram. So how to combat this thing? First we have considered ABC, and again we are moving forward and considering BCA. But what we want is, we want only A, B, C to be catered, to be to as an answer, not BCA. So to get A, B, C only as an answer, what we can do is, suppose we are moving in window of size 3. So if we get that as an anagram, we simply remove this window and we again start from here. So that this won't have us overlapping sub problem. Like it might be a scenario that suppose we have A, B, C, D, and here also again we have A, and the given string is nothing but A, B, C, D. So this is also an anagram, this is also an anagram, but we want only A, B, C, D. So what we can do is, whenever we find an anagram, we just suppose this is the anagram part, this becomes the anagram part, so we should start from here. Okay, fair enough. Like suppose one person is eating, let's say, a biryani. Okay, and I don't want him to overlap with the next person. So what I would do is, I would serve him biryani, and I would altogether start a new chapter from this side, so that this biryani doesn't get overlapped with someone else's biryani. This is what I would do. So in the same manner, if we have ABCD and we found an anagram, we would simply move forward. Now, how to check if each window is an anagram or not? This is an important perspective. So see, basically, to check if two strings are anagram of not, what we can do is, we know that the string contains only lowercase characters. Okay, here we are given somewhere, given list of characters and a string S. Okay, so basically here we are given a string of lowercase character. So the lowercase characters are lower a to lower z. So we would have an array of size 26. and we would map A with 0, we would map B with 1, and C with 2. How would we do that? We would subtract the ASCII value of A. So, suppose the value of A is 97, B is 98. So 97 minus 97, 0. 98 minus 97, 1. 98, 99 minus 97, 2. That is how we are just mapping it. Okay. So at each point, we would first hash the values of window of size, whatever is given. Okay, first we would have it. And then if we have found an anagram, we would simply start from that point. Okay. So basically here we need two pointers. One would point, both would point here at this point. Okay. So like let me show you. Suppose, let me just show you by hand. Suppose both would start here. Then this would move here, this would move here, this would move here. This would keep moving until the size becomes the size of the given string. When the size becomes the size of the given string, we check now it is an anagram or not. If it is an anagram, what we would do is this was here, this was here. We would simply make this go here and this go here. Okay. If this is not an anagram, so this one would move forward. Okay. So what we can say is, suppose if we have A, B, C, D, E. Okay. So first, suppose the given string is B, C, D. Okay. Or let's say this becomes very obvious. C, B, D. Okay. First, we have an pointer over here and over here. First, both pointers are pointing to the head. And we know that this is not the length of the given CBD. We want a length 3. So we move forward. This is not yet the length 3. This becomes the length 3. Now we would check if it is an anagram or not. No, it is not an anagram. So we would move this pointer ahead. Then we would again start moving this pointer ahead. Now the length is 3 and the given length is also 3. Now we would check if this is an anagram or not. This is an anagram. So what we need to do is we need to make this go after this pointer, and this one should also start from here. Like just we started from the very first. Like earlier both were here and now we are here. Okay, we make a fresh start after that character. So now this becomes an implementation problem. So we would move down to the implementation. So just give me a quick one if this thing is clear or not. Just give me a hi Prakhar Pandey, hi Rishit, how are you? Just give me a quick one if this thing is clear or not. Okay. So I think we are good enough to move forward to the coding part. So I would present the tab itself. Okay. Am I visible? Now I should be visible. Yes. So first we need to save this one. Okay. So we need to return a vector of node. So we would simply return and we would say it as res. Yes, we would store the answer in res. So now we would hash this given string. So and hash the given string and the ongoing window. So we want two arrays. So we would say vector of int of window of size 26 and sliding window of again size 26. Okay, window is for the original string, sliding window is for the moving string, moving window. Okay, now first we would hash all the values of the given string. Okay, and we would say window, like, yes, window of e minus the value of a, and we would simply hash it. Okay, after this is done, we would move forward. Now both would point to here. We would start from the head, both colliding at here. So now we would say node. So I would just copy this. Node star. start is equal to head, okay, and node start end is equals to head again. We both have the head. Now we would have a count variable to store that yes, now the window is of length 3. So we should now consider it. So we needed this one. So while the last pointer is not reaching the end, while end is not equal to null, because the last pointer doesn't mean that it is pointing to the last null. Okay, while it does not come to the null part. So we would first hash the value in sliding window, and we would say end end of data minus the value of a, and we would simply do plus plus. After hashing the value, after hashing the value, if if the sliding window is equals to the window, if it is equals to the window, then what we should do? We should push it to the vector given. So what we would do is res dot push back res.pushback the starting point. So the start. After we have found it, now we should say that this start and end. So this start should go to this point, that is ends next. So start is equal to ends next. Okay. And what we would do is ends next is equal to null. Okay. And now end is equal to start. Okay. Fair enough. Start points to the next of end. Ends next becomes null, and end is now equal to start. Both start from the same position. Now again the count becomes 0. Okay. Now we need to again, like we found a string, so now we need to reset the sliding window. So we would say sw dot resize 26 comma 0. We would resize the sliding window of size 26 with everything as 0. Else if we have not found something, the start would move forward and the end would also move forward. Okay, so end is equals to end dot next, end would move forward, and if the size is more than the size of the given substring, so we would say start move the starting point also. Like count if c is greater than equal to s dot size. Suppose the size is only 1. If the size is 1, then this should move. Okay, only this should move. That is why this is moving, regardless of what is the length. But if the size becomes more than 3, then this should move. So if size is becoming more than 3, what we should do is we should move forward the sliding window. So we would say, first we would, so if this is moving forward, then this character is going out. So we would say sliding window of start dash, okay, start dash data minus the value of a minus minus. So we would first remove the hashed part. Now we would make start move forward. So start is equal to start dash next itself. Okay. After all this is done, we would return the value of this. Now we would just compile and then see how many errors are we making. Okay. Okay, we made an error somewhere. So we started off with res is equals to so any errors. Okay, no one is. So we would hash the values of this, and then start is equals to head, and initially count is equals to null. So end dash data minus a plus plus, and then count is also increasing. if sliding window is equals to the window and dot data sliding windows data would increase. Okay, then we would post start is equals to ends next is equals to null, and then this is equals to 0, and we would make everything of sliding window as 0. Okay, and then we would say if this is else, end would move forward regardless of whatever it is. If count is greater than size of the window, then start is equals to start dash next data minus 1. So, sir, aren't you? So, why do we make? So, aren't you feeling sleepy? Because I am. That's my job, of course. So, why do we make starts and start equals to null? Which part? S- End start is equals to null. Ends next is equals to null. And start is not equal to null. Which part are you talking about? So I think we are resizing this one as for int I is equals to 0, I is less than 26 and I plus plus, and we should see that the sliding window of size I is equals to 0. I think this is causing some issues at this point, else if sliding window. hmm Why this is why this is not working, by the way, let me just see. This should work. Resize SW dot resize of size 26 comma 0. Why this is not working? Just let me see what does resize does. Resize vector in C++. Mm-hmm. Okay. 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 I should use fill instead of this. So instead of this, I should be filling up with fill. So I was writing the correct one, but I was just using resize thing. Okay. So share this tab instead. Yes. You should not use resize. Okay. So just mention the line number at which you are not able to understand, and I would be catering it. What is the reason line numbers and what is the reason for ends next is equals to null? Ends next is equals to null for safe side. See. Okay. So see. Ends next, we are making it to null. Why? Because suppose if it is pointing to the last part, and if this has a self loop or something, here it is not mentioned, but internally in the test case it is mentioned. So if it has a self loop or something, then this is not working. That is why we need to have null here. So in the cases of trees, in the cases of linked list, we need to make sure that we have a null pointer. Okay. Any more further queries you have? Just mention the line number and I would be catering it. By the way, most probably the timings of this POD stream would change. Yes, terminate the anagram interest. Yes, absolutely. So this one would change. I think the finalized thing is not yet, but I think that for this month I won't be taking up the POD sessions. Think, because today it has been discussed that I would be not moving forward with this POD thing for this month. I would be continuing from next month. I think so. Yes, yes, this is correct. This is correct. Okay, so I would be waiting for the next 30 seconds and then I would be moving forward to the termination of the stream. Uh, so I think that was it for today. So that was it from my side. If you're watching the stream in the recorded version, feel free to comment on this video or like this video so that the reach of this video could be increased. That's it for today. Thank you and have a nice day. Most welcome.